Hello grade 10s and welcome back to another video with me, Miss Martins. Right now we're going to be looking at chemistry exam questions. I know you've been waiting for this. I've done a bunch of physics exam questions and now we're on to chemistry. I'm doing November 2019. Let's get right into it. But first, please subscribe if you haven't yet. Like this video if you need help with chemistry in general, and don't forget to comment what you need help with next below. I first wanted to remind you that during every chemistry exam, you will have physical constants given to you, and these are the constants that you'll be using in your questions. For example, Avogadro's constant is given over here. We use that in stoichiometry. Then they give you the formulae, and they give you a periodic table, which is amazing. Let's jump into multiple choice questions, which, as you know, in physics and chemistry is always question number 1. Our first question says nitrogen gas is an example of and they say element, compound, heterogeneous or homogeneous mixture. Well, nitrogen gas is a pure substance. It is N2. And if we take a look at the options that they've given us, we know that nitrogen is, the answer is A. Nitrogen gas is what we call a diatomic element. And you might be thinking, wait a second, nitrogen gas is N2. I thought elements are on the periodic table, like Mg, Zn, Al, N. How come N2, nitrogen gas, is an element? Well, remember, compounds only refer to things that have two or more different types of atoms bonded together. So, for example, H2O is a compound. Okay, but diatomic elements include things like nitrogen gas, hydrogen gas, chlorine gas, fluorine gas, and so on. It's definitely not a mixture. The reason why is because mixtures are a physical combination of two or more pure substances. So, for example, two or more elements and two or more compounds. So, for example, air is a mixture. It's a mixture of gases such as carbon dioxide, oxygen, nitrogen. 1.2 gives us a heating curve, and they say during which section or sections on the curve will the potential energy of the compound increase. Now, you need to read your question very carefully because they're not asking for kinetic energy. They're asking for potential energy. So I hope you can recall that when temperature is increasing, so for B to C, that's when temperature is increasing. That is when kinetic energy increases. Okay, but that's not what they're asking for. They're asking for potential energy. So potential energy will increase when objects or when the substance is going through a phase change, right? And it's going from solid to liquid or liquid to gas, and the particles are moving further and further away from one another because the forces, the intermolecular forces between the particles are getting overcome or they are weakening. So therefore, A to B represent a phase change. The temperature is constant, the kinetic energy is constant, but the potential energy is increasing. And the same thing can be said with CD. Temperature is constant over here, 300 degrees Celsius. Therefore, kinetic energy is constant because temperature is a measure of the particle's average kinetic energy. And then basically, because it's going through a phase change, the potential energy of the compound is increasing. So our answer is C. 1.3 says elements in the periodic table are arranged in order of increasing, and then it gives us 4 options. And our answer over here is number of protons. Another phrase to represent the number of protons would be the atomic number. If we look at the periodic table, you should have learned that the periodic table is arranged in the order of the increasing atomic number. So 1, 2, 3, 4, 5, 6, and so on. The atomic number is equal to the number of protons. The next question, they give you an unbalanced equation of a chemical reaction. We've got methane, which is CH4, reacting with oxygen to form carbon dioxide and water. This is an example of a combustion reaction, just by the way. It's a combustion of alkanes, which you'll learn more about in grade 12. But they want to know which one of the following represents the coefficients of reactants and products in the balanced equation. So basically they want us to balance this equation, and we know that the coefficients are the big numbers when the equation is balanced. So for example, if that's a 2, if that's a 1, and so on, but we need to balance it properly and then we'll choose our answer. When balancing a combustion of alkanes reaction in grade 12, you'll learn a little bit of a shortcut when it comes to balancing. It's just a little tip that we teach you, and it is that when you have a reaction that contains carbons, hydrogens, and oxygens, which you do when you have oxygen reacting with an alkane, which is something that looks like this. An alkane is an organic compound that contains carbon and hydrogen and single bonds. That doesn't really matter, but the trick is you first balance the carbons, then the hydrogens, then the oxygens. You may need to use fractions, and if we do, we'll deal with that when we get there. So let's do the carbons first. So if you look at the balanced equation, we've got one carbon over here, one carbon over here, therefore the carbons are balanced. Hydrogens, if we look at the hydrogens, there's 4 on this side, and over here there are 2. So hydrogens, 4 over here, and over here we've got 2, which means I need to multiply this by 2. Because we need to multiply the hydrogens by 2, I'm going to put a big 2 over here in front of H2O. Now, because I've multiplied the hydrogen here, H2 by 2, I now have 4 hydrogens. See, 2 times 2 is 4. However, I also now have 2 oxygens over here, plus these 2 over here. So we've done the hydrogens, they're now balanced. I've got 4 hydrogens here, 4 hydrogens here. Now we're going to do the oxygens. So for the reactants, let's count the number of oxygens that we have. We have 2 on this side, okay, O2. On this side, like I mentioned, we have 2 over here plus 2 over here. So 4 in total. Once again, 2 over here plus 2 times 1, which is 2. 2 plus 2 is 4. Okay, so 2 there, giving me 4. So how am I going to make this work? In order to make this left-hand side also have 4 hydrogens, I need to multiply the oxygen by 2. And that's it. Just remember when balancing that we always change the coefficients if we need to. We either put a number here or whatever. We never, ever touch the little numbers. Never. Okay, that's just a rule. We never do this. This is because the big numbers over here affect the number of molecules or the number of compounds. So this 2 now means that I have not 1 oxygen molecule, that's 1 oxygen molecule, but 2 oxygen molecules. But each oxygen molecule has 2 oxygen atoms. This 2 over here means I have 2 water molecules. This is what water looks like. Because there's a big yellow 2 in front of it, it means I have 2 water molecules. Number 1, number 2. But in each water molecule, I still have 2 hydrogens. That's why it says H and a baby 2. And 1 oxygen, which is why it's just O. Okay, I hope that makes sense. So therefore, our answer is C, because all we've done is we've changed that coefficient from 1 to 2, so there it is there, and we've changed this coefficient of water to 2. The coefficient of methane, of CH4, is still 1, and the coefficient of carbon dioxide is still 1. A covalent bond forms, and then we have to choose the most correct answer. Definitely not between a metal and a non-metal atom, because that is ionic bonding. Through electron transfer, definitely not, because again, that is ionic bonding. Through the sharing of electrons, yes. Covalent bonding is between a non-metal atom and a non-metal atom, and it's the sharing of electrons. D is also incorrect because it's not between positive and negative ions. That again is ionic bonding. If you need more help with ionic bonding and covalent bonding, check the playlist linked above. The reaction between hydrogen and chloride, HCl, and sodium hydroxide is an example of a or an. Then we have to say redox reaction, acid-base, precipitation, gas forming. This one is a nice straightforward one. Hydrogen chloride, that is a strong acid. Sodium hydroxide, that's a strong base. This is an example of an acid-base reaction, and our products of this reaction, not that they're asking, but if you were to complete the equation, it would be NaCl plus H2O. It's an acid-base reaction because the acid donates the proton to the base, so a proton is an H+. So the OH- part of the base will accept that proton, forming water, and then the leftover bits, so the Na and the Cl, the Na plus ions and the Cl minus ions will form NaCl. So we will go over acids and bases at some points in the year, so just keep an eye on my channel for videos about that. 1.8 gives me an Aufbau diagram of an element. So it's not an ion, it's an element. They tell me it's an element, and they say the element is A or an, and we have to choose from the list of groups over here. Now, first step is to look at the Aufbau diagram, and I would count the number of electrons. So we've got 2, 4, 6, 8, 10, 12 electrons. And with that bit of information, we can look at the periodic table and we'll be able to tell which element this is referring to and therefore which group it's in. So 12 electrons. Remember, electrons can be found if we look at an atom. If we look at the small number, that's the atomic number, which is the number of protons, but also the number of electrons in an atom. Okay, so 12 is my number, and we know that that is magnesium, and magnesium is in group 2, and we know that group 2 are the alkali earth metals. So therefore my answer is D, the alkaline earth metals. Question 2, they say that most elements found on Earth are metals, and all metals have a metallic structure, and we know that that involves metallic bonding. Now 2.1.1 asks us for the type of particles present. So by this we have to refer to the type of particles present in metallic bonding, essentially, that makes up the metal, and that answer is positive ions and delocalized electrons, because remember, the delocalized electrons essentially hold the positive ions together. They form like a glue, like a paste. So this is essentially what we're looking at. We're looking at positive ions left over and a bunch of delocalized electrons. Now, delocalized basically is an electron that's not connected to a single atom. See, it's not connected to any one of these positive ions. It's basically just floating around between these positive ions, connecting them like a glue. Okay, that's how the textbook describes it. It forms almost like a glue or a paste, connecting the positive ions together. And because of these delocalized electrons, that is what makes metals such good conductors of electricity and of heat. Then they say the type of chemical bond formed between these particles, and as we said, that's metallic bonding. In which region on the periodic table are metals found? Choose from left or right. Now, you should know, you should be aware that metals are found on the left-hand side of the periodic table. So if we look at the periodic table quickly, we can see that all of these are metals. Okay, we've also got some transition metals, and then also some metalloids, which are kind of along this area here. But hydrogen is also on the left-hand side of the periodic table, but we know that hydrogen is the exception. That is actually a non-metal. 2.3, write down the symbol of a metal, which is a liquid at room temperature. And you should know that that is mercury. But look at what the question says. It says write down the symbol. So if you write out the word mercury, you're going to get it wrong. So you have to say Hg. 2.4, to prevent iron from rusting, it's often mixed with other metals. Stainless steel is a mixture of iron, chromium, and nickel. Is stainless steel a homogeneous or homogeneous or heterogeneous mixture? Give a reason for your answer. Now the answer is homogeneous or homogeneous, and the reason is because stainless steel has what we call a uniform composition, and that means that the separate particles cannot be distinguished. We can't tell them apart. We can't say, oh, there's the iron, there's the chromium, there's the nickel. It all looks uniform. It all looks the same. Another way to explain it is to say that all the components are in the same phase. So there we go. There's your answer. Then 2.4.2 basically explains rusting. They say rusting is the formation of iron 3 oxide. Write down the formula. Now, as you know, or as you should know, the 3 in the brackets over there represents the charge of iron. Iron is a transition element, which means that it can form one or more different types of ions. So here's iron. It's in this middle block of the periodic table, which represents the transition element. So iron can form Fe3 plus ions. It can form Fe2 plus ions. It can form Fe plus ions. So they need to give me the charge of iron so that I know which ion I'm dealing with. Okay, so iron 3 oxide. Fe is a symbol for iron, and we know the charge is 3. So plus 3. Oxide is oxygen. And as you should know, the charge for oxygen is -2. How did I know that? Well, because if you go to your periodic table, once again, the periodic table is super cool, super helpful. You need to know it. We know that the group 1 metals charges is +1. The alkaline earth metals is +2. Then we skip this middle block because those are the transition elements. Then we've got +3, plus -4, -3, -2, -1, and 0. Okay, so oxygen over here has a charge or a valency of -2. Now, in order to form iron oxide, we need the charges to equal out. We need them to balance. It needs to form a neutral compound. In other words, the overall charge of the compound must be 0. Now, how do I get that right? Because at the moment, 3 minus 2 is definitely not 0. So what I basically do is I find the lowest common multiple between these, which is 6. And I say, okay, how do I make 6? I need to multiply this number by 2. And I need to multiply this number by 3. What that means is I need 2 ions. I need 2 of those. And I need 3 oxygens. When I have 2 ions and 3 oxygens, then I have a neutral compound like that with an overall charge of 0. There we go. That's the name. Iron 3 oxide looks like that. It's a little bit more difficult if they give you this formula and they ask for the name, because we know that Fe is iron, but we know because it's a transition element, it needs brackets over here with the Roman numerals telling me about the charge. And we know that oxygen will be oxide. So how you figure this out is you say, okay, oxygen has a charge of -2, but it was multiplied by 3. This ion over here, Fe, was multiplied by 2, which means that its charge must have been 3, and that's where the 3 comes from in the brackets. If you need more help with this, I do have a video on naming on my channel, so you go check that out. 2.5 gives me the physical properties of two substances A and B, and we know physical properties are things like the strength, the density, conductivity, all those sorts of things. And over here they give us 3 of those. They want to know which one of the substances A or B has a smaller mass to volume ratio. Now you should know that mass to volume ratio, another way to write a ratio is to write it in a fraction like this. And you should know that mass divided by volume is equal to density. So they basically want to know which one has a smaller mass to volume ratio, which one has a smaller density. And if you look at the density values, A has the smaller density. So your answer is A, and you can say smaller density or lower density. I think lower density is probably a better English. Explain the difference between electrical conductivity and thermal conductivity. Now, as soon as you see electrical, you need to know, okay, cool, electrical conductivity is current, it's charge. So electrical conductivity is the conduction of electric charge or electric current. If you see thermal, you need to think heat. So thermal conductivity is the conduction of heat. In questions like this in physics and chemistry, when they say explain the difference between, and they give you 2 things, you need to give me an explanation for both. You need to compare them. 2.5.3 says which one of the substances A or B is a metal. Give a reason for your answer. So if you look at the table, we can see that B is a good conductor of electricity or electrical conductor, and it is a good thermal conductor. Therefore, B is my metal. Another reason would be if you look at the densities, B has a much higher density, and we know that metals have a higher density. They just want one reason, so we can choose. Question 3 has to do with isotopes. Now you need to know that isotopes are different atoms of the same element that have the same atomic number but a different mass number or a different atomic mass number, and that's because their number of neutrons differ. So for example, let's pretend that chlorine has 2 isotopes over here. We can see that their atomic numbers here are the same. That means that their number of protons are the same. 17 protons here, 17 protons here. However, you can see that their atomic mass numbers differ. And that tells me that this isotope of chlorine will have 18 neutrons. How did I get the number of neutrons? I took the atomic mass number minus the atomic number, and this one over here will have 19 neutrons. So basically they are atoms, different atoms of the same element. So this represents one atom. In this atom, there's 17 protons and 18 neutrons. In this atom, there's 17 protons but 19 neutrons. So different atoms of the same element. They both belong to chlorine. They have the same atomic number or the same number of protons, but a different atomic mass number or different number of neutrons. So I'm going to paste the definition for you on the screen so that you can study it. There we go. Then the next question wants us to work out the relative atomic mass of magnesium, which takes into account the percentage abundance. So for example, magnesium here has 3 different isotopes: magnesium 24, magnesium 25, magnesium 26. So it's kind of like getting an average of these 3 numbers, but it takes into consideration the percentage of abundance of each of them. And the relative atomic mass, okay, or the nearest whole number to the relative atomic mass is what we see on the periodic table. Okay, so for example, for chlorine, it says 35,5. That is worked out by considering all the different isotopes of chlorine and their abundances. And they work out the relative atomic mass using the formula that I'm going to show you on the next page. But we're going to do it in this question for magnesium 24, magnesium 25, and magnesium 26. So if we look at the 3 that we've been given, magnesium 24 has a percentage abundance of 80%. Magnesium 25, 10%. Magnesium 26, 10%. How did I know to match up the percentages to the names like that? Because they say respectively, which means that the one that's mentioned first matches with that percentage. The one that's mentioned second matches up with that percentage, and so on. So when calculating the relative atomic mass, we use the following formula. You take the mass number times the percentage abundance. And then we'd say plus. Then we take the second mass number times the percentage abundance. And then we say plus. And we take the third mass number times the percentage abundance. Now, why do I have 3 brackets? Because I have 3 isotopes. If I had 4 isotopes, I'd have 4 brackets. If I had 2 isotopes, I'd have 2 brackets. And we divide these all by 100. Okay, so let's do it. We take the mass number of the first one, which is 24, times it by the percentage abundance, which is 80. I know it's 80%, but we don't put the percent sign in over here because we're already dividing it by 100, which takes into account the percentage. Then we add 25 times 10, because you take your mass number times the percentage, plus 26 times 10. The mass number times the percentage. We divide all of that by 100, and we get 24,3. Now, if we look at magnesium on the periodic table, we can see that 24,3 is basically rounded off to 24, which we see on the periodic table. In the next question, staying with electrons, protons, mass number, atomic number, that thing, they give me the number of protons and electrons and the mass number of magnesium 24 and its ion are shown below. So we've got magnesium and we got its ion. Some of these values have been omitted, which means have been left out, and we need to fill them in. So now, first of all, number of protons, that refers to the atomic number on the periodic table. And the number of protons will never change. So the number of protons never ever changes. And that's because an atom can't lose protons. Okay, it can lose electrons, it can gain electrons, but it can't lose protons. So you look at the atomic number, the small number on the periodic table, and that's your number of protons. Number of electrons. For a atom, for the magnesium atom or for an atom, that would be the same as the number of protons. So it would also be the atomic number. But electrons can be gained, electrons can be lost. So therefore for an ion, electrons will be different. I hope you know that. For a cation, cations are positive, cats positive. For a cation, such as the magnesium ion actually, or let's say like a sodium ion or something, that means that we've lost electrons. And if that's a bit confusing, think about it like this. Electrons are negative. If you lose the negative stuff, you become positive. You become a cation, and cations are positive. Anions, those are negative ions, like the chloride ion or the oxide ion. Those gain electrons. And that makes sense because electrons are negative. So if it has a charge of -2 or -1 or whatever it is, it means it got extra electrons. So therefore, in the case of ions, the number of electrons will be different to the number of electrons in an atom. The mass number, that is the big number on the periodic table. So I'm going to say big number. And the mass number is the number of protons plus the number of neutrons. So remember, the mass number will be different for isotopes, but for an atom and its ion should be the same. Atomic number is the small number on the periodic table, and it represents the number of protons. Okay, so with all that information, let's actually do the question. So starting with magnesium, with the atom, magnesium atom, number of protons, 12. That is also the same as the atomic number would be 12. Okay, number of protons is the same thing as atomic number. Then in a neutral atom, so in other words, not an ion, the number of electrons is the same as the number of protons, 12. Because Mg, it hasn't lost electrons, it hasn't gained electrons. It's just Mg, so therefore the number of electrons is 12. Okay, so we got A and B down. For C, they asked for the number of protons in the ion. Now remember we said number of protons will always stay the same, so it'll be 12. No matter if the ion gains 100 electrons, it will still be 12 protons. The number of electrons, however, is different for an ion. Remember we said that Mg2+ means that it has lost 2 electrons. Now again, what the heck are you saying, ma'am? You're saying 2+ means it has lost electrons? Yes, because remember electrons are negative. So if you lose 2 negative things, you become positive. 2+ because you've lost 2 electrons. So the number of electrons will be 10. Then the mass number for the ion, for Mg2+, will also be 24, because remember mass number is number of protons plus number of neutrons, and just because this thing is now an ion, Mg2+, doesn't mean that it has extra neutrons. Only isotopes may have a different number of neutrons. 3.2 gives SP notation of an unknown element, and for the element they want the number of valence electrons. So valence electrons are the electrons in the outer energy level. So if we look at the SP notation, we can actually find this pretty quickly. Energy level 1 is full. Energy level 2 is full. Energy level 3, however, is not full. Now, first of all, how do I know that energy level 1 is full? Energy level 1 only has an s orbital. It can only hold 2 electrons. Energy level 2 can hold a maximum of 8 electrons, 2 in the s orbital and 6 in the p orbital. Energy level 3 can also hold a maximum of 8, but it has 2 plus 5, it has 7 electrons. So therefore the number of valence electrons is the number of electrons in the outer energy level, which is energy level 3, and that is 5 plus 2, which is 7. The period where this element is found on the periodic table, the period in which the element is found, corresponds to the outer energy level. So therefore energy level 3. The highest energy level in which electrons occur, again, our last electrons are occurring in energy level 3. And then they want to know the symbol. So there's 2 ways to quickly find this. We can either add up the number of electrons and get the total number of electrons and locate it on the periodic table. So I get a total number of electrons of 17. You add all the small numbers. So 2, 4, 6, 2 plus 2 plus 6 plus 2 plus 5 gives you 17. And if we look on the periodic table, the atom with 17 electrons is chlorine. The second way to find out that it's chlorine is we already said that it's in period 3 because its outer energy level is period 3. So this is period 1, this is period 2, this is period 3. this over here represents the s orbital. So this would be 3s1, this would be 3s2. This would be 3p1, 3p2, 3p3, 3p4, and 3p5, which is where my SP notation stops. But the easiest way is definitely just to count the total number of electrons and locate it on the periodic table, so we know it's chlorine, so the symbol is Cl. The next question says magnesium, Mg, which is a metal, combines with element X, which we've identified as chlorine, which is a non-metal, and they say that they bond to form a compound. Write down the type of bond that forms between magnesium and element X. Well, because it's a metal and a non-metal, we know that it's going to be an ionic bond. Draw the Aufbau diagram for the magnesium ion. Now, very important, they want the magnesium ion, which is Mg2+. Now, how to draw the Aufbau diagram? We start with 1s at the bottom, then we go 2s, 2p, 3s, 3p, and so on. I don't know if we're going to need so many energy levels and so many orbitals, but I'm going to see when I fill it in. We know that energy level 1 only has the s orbital, which can hold 2 electrons. 2s can hold 2 electrons. 2p can hold 2, 4, 6. 3s can hold 2, and 3p can hold 2, 4, 6. Now, the magnesium ion, magnesium itself, has 12 electrons. There we can see it over there. And we know that Mg2+, the magnesium ion, means that it has lost 2 electrons. So if magnesium has 12 electrons, Mg2+ has 10 electrons, like we said earlier. So 10 electrons, it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we have a complete outer energy level full there. Energy level 2 is my highest energy level, and we do not need energy level 3, so we can get rid of that. If you need more help on how to do the Aufbau diagram, check out my video on Aufbau diagram and SP notation. Okay, we don't need that final red circle over there. Okay, so energy level 1 is full, energy level 2 is full, and that makes sense that the outer energy level is full because magnesium ion is full and stable, outer energy levels complete. Our next question says draw Lewis dot diagrams to show the bond formation between magnesium and element X, which is chlorine. Now we know that it's an ionic bond, which means that there's a transfer of electrons. And we know when we do ionic bonds, we're going to see brackets, we're going to see charges in our final answer. If you don't know what I'm talking about, go watch my video on ionic bonds. So draw a Lewis dot diagram to show the bond formation. Now grade 10s, when they ask for the bond formation, and it's 4 marks, they want the entire process. So they want you to say this plus this gives me this. All of those Lewis dot diagrams, not just the final diagram. So we've got magnesium and the number of valence electrons in magnesium. Okay, we can look here at the Roman numerals is 2. Magnesium has 2 valence electrons, so I'm going to represent them with dots. 1, 2. A chlorine atom has 7. Chlorine over there has 7. Roman group numerals, that means 7. I'm going to represent them with crosses. 1, 2, 3, 4, 5, 6, 7. Now, we know, if you watch my video on ionic bonding, you will know that this needs to reach an octet structure, which means it needs 8. One of these electrons from magnesium will be transferred to chlorine. That's why I wrote here ionic bonding is a transfer of electrons. However, magnesium needs to give 2 electrons away, but chlorine only needs 1 of them. So therefore, this magnesium is going to have to bond with another chlorine atom. So for every 1 magnesium, we need 2 chlorine atoms, because magnesium wants to give away those electrons. So 1 to that chlorine, 1 to that chlorine. And that's going to give me the following final diagram. Magnesium now no longer has electrons around it. So we can use brackets to represent that, but you don't have to use brackets here. And that's magnesium 2+, Why 2 plus? Because it's lost 2 electrons. And then the chlorine. Each chlorine now has 1, 2, 3, 4, 5, 6, 7. So that's 7 of its own originally. Then 8, the one from magnesium. So each chlorine will form a charge of -1. Just need to write the negative in there. -1. But we have 2 of them. And that's why the chemical formula for magnesium chloride is MgCl2. In some memos, they put the 2 over there. In some memos, they put the 2 over there. It doesn't really matter, just don't put it twice. Basically, we're showing that for every 1 magnesium atom, we need 2 chlorine atoms. And that's because magnesium can give away 2 electrons, forming Mg2+, and chlorine each needs 1 electron. That's why it forms -1. Question 4 gives a section of the periodic table, and it gives imaginary symbols to represent some of the elements. So you can see that A, obviously that's not a symbol for an element, that's to represent an element. Then it says write down the imaginary symbol, in other words A, E, D, H, M, and so on, of the element that is a halogen. We know that this group 18, represents the noble gases, therefore the halogens are next to the noble gases, group 17 over there, and that would be J. Write down the imaginary symbol of the element that will form a cation with a charge of +2. So we know cations are positive, and we know that metals generally form cations, and if they're going to form a charge of +2, that means they have a valency of +2. We know that group 1 has a valency of +1. They can give away 1 electron. Group 2 has a valency of +2. A charge of +2, which means it can give away 2 electrons. So that means we're looking at E. Has the largest atomic radius. Now you need to study the trends in your periodic table. So you should know that atomic radii, or an atomic radius, decreases across a period. So as we go this way, the atomic radius gets smaller and increases down a group. Okay, so that means this way, these ones on this side will have smaller atomic radii, and as you go down, then it also increases. So decreases as you go across the period. So as you go from A this way, it decreases. So these are the smallest ones, and increases as you go down the group. So therefore A has the largest atomic radius. Then 4.1.4 says has the highest electronegativity. So you should know that electronegativity increases as you move from left to right across a period. So as you go this way, it increases, and decreases as you move down the group. So it increases as you move from left to right, and it decreases as you move down the group. This is just something that you need to study. So taking those trends into consideration for highest electronegativity, we know that the imaginary symbol that will have the highest electronegativity would be J. And you might think, but ma'am, why not L? Because we said as we go to the right, it increases, and as we go down, it decreases. So wouldn't L have the highest electronegativity? Go look on your periodic table and tell me if noble gases have any electronegativity values associated with them. The answer is no, and because remember, electronegativity is basically the measure of an atom's ability to attract shared electrons when it is bonded to another atom to itself. So if you have a high electronegativity, you have a greater ability to attract those shared electrons, and you pull it closer to yourself. But we know that the noble gases don't bond, especially the higher up noble gases. Okay, helium is very low in reactivity. It doesn't want to react, doesn't want to bond. For 4.1.5, they want to know which atom is a metalloid. And the metalloid, another word for metalloid, is a semi-metal, so it has properties of both metals and metals, so that would be H. If you look at your periodic table, there is a step that you can draw on your periodic table, and around that step, H is one of those elements. H is actually germanium, and it is a metalloid, it is a semi-metal, it has properties of both metals and non-metals. Then they want to know 4.1.6, which one is a noble gas. So we mentioned that L is the noble gas. which will form a diatomic molecule? I would immediately say J because it is a halogen. We know the halogens form diatomic molecules, but you can also say G. And that's because if you look at the position of the imaginary symbol G on the periodic table, you can see it's in group 16 over here. So next to the noble gases in period 2. And that essentially corresponds to oxygen, which we know can form a diatomic molecule, oxygen. Okay, so G or J has 3 valence electrons. We know that this group has 1 valence electron, this group has 2, this group over here has 3 valence electrons, so your answer is D. 4.2 says the first ionization energy of element A is 400 kilojoules per mole, and they want us to define ionization energy. You know, in chemistry, definitions are very important. You need to know them. So I just copied and pasted it here. The first ionization energy is the energy needed per mole. You have to say per mole because look at the unit. That says per mole. That is needed to remove the first electron from an atom in the gaseous phase. This is a definition that you have to study. And now I hope you guys can remember that the higher your ionization energy, the more energy you need to remove an electron from an atom, the more difficult it is to remove an electron from an atom. And that's why noble gases have the highest ionization energies, because noble gases don't want to get rid of their electrons. So they want us to complete this equation. So we've got A in its gaseous phase. That's important according to our definition. We've got our ionization energy. Now remember, ionization energy is the energy needed per mole to remove the first electron from an atom in its gaseous phase. Okay, that's what gas is, why gas is there. But now think about it. If I take an electron away from A, what's going to happen? You take away a negative thing, an electron. You're going to leave A with a charge of plus. And then you're going to have that extra little electron that you removed. So those are the 2 things that you need to fill in there. When the electron is removed, A becomes plus, A plus, because you've now taken away the electron, and then you need to just write the electron in there. 4.3 says atoms of element J release the most energy when gaining electrons to form negative ions. Write down one word or term for the underlined phrase. So they're sort of giving you a definition here, and they want one word or term. So that is electron affinity. Okay, electron affinity. And we know that the atoms or the elements with the highest electron affinity will be, for example, the halogens, because they want to form -1 ions very, very easily, because they want to gain those electrons to reach a full outer energy level. That's why they form Cl- or F- or Br-. They need one more electron in order to reach a full outer energy level. 4.4 says write down the formula of the compound formed when D combines with G, and then the second one when A combines with J. So in order to write down the formula of the compound, we're going to pretend that these imaginary symbols are our elements. We need to find out the charges or the valencies of these things and then see how they combine. Okay, so how we do that is we look at the imaginary little table they've given us. So D and G. So D is over here, G is over here. As we know, this group will have a valency or a charge of +1. This one will be +2. This will be +3. This will be ±4. This will be -3, -2, -1, and 0. So D has a charge of +3 and G has a charge of -2. So those are the charges or the valencies. Remember, I need to make a neutral compound with an overall charge of 0. In order to do that, I need to find the lowest common multiple, which is 6. So I need to multiply this one by 2 and this one by 3. So I'm going to have D2G3. The little number you put here is whatever you multiply the charges by. Then for A combining with J, A has a valency or a charge of +1, J has a valency or a charge of -1. Therefore, in order to make our overall charge of our compound equal to 0, a neutral compound, +1 -1 does equal 0. So we've got A, J. We don't need to put the ones there. We technically can multiply each of these by 1, but we technically don't have to. So it's A, J. I hope that makes sense. I hope you liked this video. Please let me know what else you want to see in the comments. In part 2, I will be doing the rest of the paper, which includes a quantitative aspects of chemical change or stoichiometry. Please give this video a thumbs up and don't forget to subscribe for more maths and science help. See you guys in the next video.